Maxwell Doolin. This is the founder of the Spokane Cyber Cup, and this is the second of the series of the Hackmon challenges, or game hacking. In the first challenge, we learned that the passcode that this computer was asking for could just be found by looking at the actual binary itself. If you run strings on it, like we did before, then we get the flag, which is super cool. However, there's a second challenge with this, and this says, "Did you hear that? It came from outside. What could it be?" And then it says the hint. Move this for a sec. Hint: the solution requires editing a byte or two in memory while the game is running. First, find the relevant byte. BT dubs. Does your emulator have GameShark support? So, it looks like we need to go outside. And you should keep in mind this computer. So, we're going to walk outside now. And we walk outside. And we have another computer here. But the thing is, there's no way to get to it. We can go here, and no matter what we do, this thing just seems to be blocked off. And this is what the hint means by editing memory. In order to get into that computer, we're going to modify the memory of the running program in order to change our location to be next to that computer. And there are different ways to go about this. Ken solved it, or Ken's the creator of the challenge, and Ken solved it a different way than I did. You can use GameShark cheat codes. In this case, I like some a little bit different though. So within the MGBA, there's some game state viewers, including viewing memory. If we click view memory, we get this different screen that comes up, and I really like this screen. I'm going to move this over because we actually don't need this very much anymore. And we have these different places of memory that we have. And they all do different things. So video RAM, external RAM, working RAM, game pack, memory wrapped I/O, high RAM, object attribute memory. There's a lot of different things that we can see here. And the way that I tend to find stuff is I try to see what changes when I do particular actions. So if we go to game pack, it looks pretty stagnant, so that might be the running code. If we go to video RAM, kind of seems stagnant when we're not moving. Kind of just seems stagnant the whole time. There's probably things like sprites and other things. If we go to external RAM, it's not really used. It just looks like it's all Fs. And if we go to working RAM, we see some data going. Here, we see a value that appears to be a timer. And we see something here that looks like it's alternating on and off and between various values. Now, when I try to find out how something works, I do an action, and I see if anything changes. So what happens there? Okay. It looks like we see some values up here that are changing whenever I move. That's helpful. Some of them seem kind of stagnant, though, which indicates that maybe it's a relative coordinate or something along those lines. If you do this enough, you'll start, and you look at these, you'll start to notice which ones get modified when you move. And I believe it's C0BB. And if we go here, we'll notice that the 7 will move when we go far enough. And this one moves going sideways when it's small enough. Now, if we go up, you'll notice that this one decreases, and this one increases when we go down. So it looks like these bytes represent vertical movement, and these bytes represent horizontal movement. So based upon that analysis, we can see where the bytes are in memory that we need to modify. And at least in MGBA, right now it's set to 3, and if I just go in and set this to 0.4, we're now inside of this block. And if we just move forward, we can then move and press X, and we're in the middle of the TV, which is super exciting. So using that memory editing trick, we were directly able to modify memory to get the flag. Now this is the way I solved it. The way Ken solved it seemed to be slightly different. I think I can modify this to go backwards. At least I hope I can. Right now it's at 4, and I bet if I modify it to 3, we'll be there, and I can walk back out again. The way that Ken solved it was a little bit different, and I'm just going to look at the solution guide because that's easier. He says that you can enable a cheat in GameShark with this specific thing. The above cheat is setting the VRAM bank 1 to 5 at some address. So we're changing the value at some spot is all this is really doing. So it's doing what we did, except it's using it as a GameShark cheat instead of just doing it dynamically like that. Now if we go to game overrides, nope. Yeah, maybe this doesn't have GameShark. Cheats. Add new code. It's GameShark code. And I've actually never tried this before, so I'm going to do save. Nope. Load. Nope. Yeah, I'm not totally sure how to use this one. I'm trying to figure this out on the fly, I will admit. I needed the code there. That's probably why. Now, I just changed that to that GameShark code, and now it works. If I press X, I'm inside of it, and so I can read the flag again. Now, both of these accomplish the same thing, doing slightly different things, or slightly different techniques. But the goal of this, as a recap, is to get within this box. And we can get within this box by scrolling down and looking at the memory. Once we look at the memory, we can see what values correspond to our movement, and we can edit it to get this within this box. This is a really fun challenge. Thanks to Ken Price for writing it up. Thanks for coming, everyone. Talk to you later.